Okay, so okay, one more time. So you must know very clearly that the initiation is the easiest. Okay, so initiation, right? So initiation, Cl, half arrow, make sure half arrow, UV light 2Cl dot radical. Understand? If, so this homolytic fission, right? So this is homolytic fission. So if I have something else, because sometimes A level asks heterolytic fission, right? Then how? Cl dash Cl. So if I have a full arrow here, what are the products? Any idea? Cl minus. Cl minus, okay. Okay lah. And the other guy? Very good. Just very clear, right? Oh, very clear. Okay, so go back to the first one. Very good. So propagation, you're right. Propagation, but I got a few things to say. Please take note. So this is the reactant again. This is a reactant plus the radical. The radical can't wait to, okay, so there's no choice. Can't wait to join and form something. Okay, they can't wait. In the meantime, this one will go over to this. Okay, so you get this here. Now, let me ask you a question. What is this radical called? Primary, secondary, or tertiary? Very good. Tertiary radical. Stable or unstable? As compared to primary, primary lah. Why? Donating or withdrawing? The tertiary means got 3 or something, right? Is it donating or withdrawing the alkyl group? Alkyl group is like all the C around. Very good. Radical, they want or don't want electron? Yes, so donating good lah. Okay, so that's the idea, right? Okay, then this part will form here. Okay, and then you form. So all this you need to know, very important nowadays, very a lot of application, and Cl dot and the chain reaction continue. Now, okay, no, later. Termination, fast one. Termination, right? So Cl dot plus Cl dot. Okay, I follow your school, need to draw this. Okay, Cl, then Cl dot plus this thing. Okay. Yeah. So this part over here, I draw properly. Okay, and the last thing. Okay, now as I finish drawing, right, you need to think through, right? Look at the 3 termination products, right? Which is of the lowest amount. That means at the end of this whole thing, right? Which is of the lowest quantity or lowest amount compared to the other 2. Any idea? The first, the second, or the third? Yes, 1. Very good. So this is important. A level level test. So this is the lowest proportion. Why? No, not least reactive. Not least stable. Most stable. No. Okay. Now, in order to form this guy, it involves 2 of these, right? And that 2 is actually what? This is called the ion. Form gone. Yes. So intermediate means is of the lowest proportion in the whole reaction. Because I form, you sub. So if that product involves 2 intermediate, then it's of the lowest proportion. Okay, so the guy's the intermediate, right? The radical, then tertiary radical is intermediate. But chlorine radical is called what? It's like C. I use that, I regenerate, I use again, I regenerate, use again, inside C. Yes, correct. You need to know these 2 terms, Japanese. Okay, perfect. Okay, so this part is the important part for your free radical sub, which I think you got it right. Very good, practice. Okay, the next concept, I just dive in concept enough. Then we'll try questions, which is very important. Now, let me show you something. Try. So if I have this product and I undergo monosubstitution, how many different products will be formed? Very good. What are the proportion? This one concept, we move on fast. You can draw out or you can mental sum up to you. So how many different products? Okay, 3 is correct, but what's the proportion of the 3?
The middle, the one in
The side
is
guys.
the
How many? What's the proportion? What's the ratio? What is to what is to what?
For ratio is
for ratio.
6:4 is to 2.
Very good, which is 3:2 is 5. Very good. Okay, so okay lah. Just for I think you know this concept, but this will be 6, right? Then this will be 4 because of 4, right? And the last one will be 2, right? Because of this thing here, right? I just put it here. Okay, now what if I change this product? I mean, I change this reactant to be this. How many different products will be formed? And what is the proportion, right? So level 2 kind of question, this one. First of all, you answer me how many different products will be formed first. Very good. Is it 1, 2, 3, 4, 5? Very good. So I believe you also know the proportion. Tell me.
6 to 1 to 2 to 2 to 8 to 2 to 2 to 3.
Okay, very good. This concept you already know, right? Now, last thing before we move on, twist your brain a bit. C8H18, this is an alkane with 8 carbon. How do you draw in a way that there's only one product, one mono sub product? Right, so one mono sub product. So you need to be creative a little bit. How do you draw C8 in a way that end up with 1? You draw straight chain, you are dead, right? Cyclic, Alright, very good. So cyclic will be C8H69. So it's not cyclic. Alkane will be no double bond, no arene. It's just alkane. Okay? Okay, maybe 10 seconds. Think first, then I will tell you how to draw in a way that I can get it. I can get only 1. It got to be I think it's a very funny question, but it got to be very branch, right? Okay, so let me guide you. Don't waste time. I came up before an exam. This is the answer. So the exam come out, then you straight away can get it. You agree only one product? Azan. Okay, and not too bad, right? Very good. Resume. Okay, so this is your electrophilic addition. Very clear one. What organic family or homologous series only that? Or you won't change one. I feel that's easy because it's that. So your brain, alkene, won't change one. Now, so delta plus, delta minus, right? So slow, very good. So this guy, full arrow will attack this. This one will break off. Okay, so Br minus over here, correct? Easy. Now, so your thought process is correct that you got to form the stable one, but let me teach you a shortcut. Now, so who enters the alkene first? Who? H or Br? H. Now, the atom that enters first enters to the carbon with more H. This one. Hold on. The atom that enters the CC double bond, attach it to the carbon with more H means what? Can you see that this guy got 2 H's, right? This guy only 1 H, right? Your thought but also okay, but I want to give you another weapon. So attach to the carbon with more H. So straight away, put in here the H, right? So this guy become a, hey, stop rubbish. This part here no H, right? Sorry. Rubbish. Okay, one more time. Wait, okay, repeat again. Now, I should do it from here. This guy got 1 H. Okay, that guy no H, I'm sorry. So attach the first atom that enters the double bond with more H, attach here, which is the same as your top. All the same one. Understand? Okay, and this is called the major product, and it's also called the mechanical product, right? Mechanical rule product, understand? Okay, then after that, easy already. Okay, so remember, attach the first atom to the carbon with more H. Then the Br minus will come and attack here. Do you draw it this way? All right. Very good. Okay, so this is fast, right? And that this one over here, need to draw anymore. So this one becomes Br. Understand? Now, so this is the first variation, like mentioned the variation. What if it's bromine? Means 2 bromine, right? What if it's aqueous bromine? Okay, so I won't draw again, but what if it's aqueous bromine?
It will still be
Which step is still the same, first or second? Aqueous bromine. Aqueous bromine versus bromine liquid. The first step is the same. Means what? What's the meaning of first step? Same. First step is whether aqueous bromine or liquid bromine, the first step is still the same, right? But it's the second step that is different. What's the difference? Very good, but we don't really say that way. Okay, hold on. So here we Br, here we plus. Okay, different school, different again. Is water. Cannot see OH minus. The water will fly in to attack Azan. Right, to get the fast step. Okay, so take note, the water will fly in. Okay, this one also different school, different. I don't know if you see before this one. Is it that? No choice. Then this part will break off to form like OH lah, but not from OH minus Azan. Okay, so this part here will be a OH, and this part will be a Br, and then there's some H plus if you want to write. Okay, just be clear, then we can focus on practicing, but got to be clear. All this should be, you must know it very well. Very good. Level 3 kind of question is they give you not only aqueous bromine in NaCl. How do you adjust? First step is still the same. This is the first step. The first step is still the same. But how do you adjust in NaCl? What are the competitors? Okay, aqueous bromine, there are 2 competitors. If it's aqueous bromine, there are 2 competitors, Br minus and water, right? Now, in NaCl, there are how many competitors? Yeah, so there is the Br minus, which is like the classic. There is water, right? There's water, and there is the third competitor called Cl minus. Understand? But let me tell you something. The first step is the same. Means must know this the first step is same. Means it die the first Br. Okay. It cannot be ClOH. It must be Br, OH, or BrCl. Okay, so this is another concept you need to know. Understand? Okay, so for this case, very good. So just to confirm again, break over here, right? Break over here. Then this part will, because it's an aldehyde, right? And this part will form a ketone, correct? Aldehyde will further oxidize to carboxyl. You know what's the difference between aldehyde and ketone? You got it right lah, but just for the sake, because in a few chapters later you learn that. So this is aldehyde or ketone. This is aldehyde or ketone. The left and right, which one is aldehyde, which one ketone? Which one can further oxidize? Left or right? Left. So this got a aldehyde. This got a ketone. Very clear. Okay, can I? Now, okay, copy that now. But now we're going to do a more difficult compound to learn something. Okay, same thing. Strong oxidation, KMnO4, dilute H2SO4, and heat. Break double bond, break double bond. Okay, hold on. I want you to try. Okay, break that. Break now. You must be alert that the first molecule you draw, which is the okay. And as a student, in order not to careless, I don't follow the angle you are interested in. You understand? Okay, hold on. Similarly to the other one, right? I follow angle means because a lot of students after that lack of one carbon, then not worth it there. You see now, I never change my angle. See, I never think do it count how many. I know that. Sure, correct. Okay, so this is a good habit as you do more. In case it's very complicated, you just piece it out and put it. Okay, now you must be alert that this guy is called ethane dioic acid, which will be further oxidized to form 2CO2 and H2O. So it doesn't exist, it will continue the oxidation, and the final products are these two together with this red dye. You cannot draw that. You cannot draw that one. Okay, draw working can. So must recognize ethane dioic acid is okay like that way. Skeleton, I think you can see, but just to confirm, is 2 acid with 2 carbon. Ethane dioic acid. You understand? Okay, okay. Now there's one more acid that shouldn't occur, shouldn't exist. You continue. What is it? This one. Okay, hold on. Terminal alkene. You know, remember terminal alkene not? Okay, so you chop here, then can you see this part here will be like that. Also will not exist. It will form CO2 and H2O. This is called carbonic acid. H2CO3. So you must be very clear. 这个 and 这个 will not exist. It will continue to be CO2 of the cells. Understand? Okay, so please take note of that. Okay. Yeah. So first of all, homolytic fission occurs only in the initiation step. Actually, this one, because your school taught you the mechanism, the arrow, this is, oh yeah, okay. So this is true or false? False. Why? Why false? Yes, which one? Yeah, so it's homolytic fission occurs in initiation and propagation. Plus propagation. Okay. Second one, chloroethane is formed in the propagation termination. Correct, right? Yes, very good. Bond formation occurs only in termination. Answer is wrong, right? Why? Occurs also. Yes, very good. Okay, so we practice, then we know these are totally different from notes. I feel. So answer A. Very good. Okay. Okay, take note. Number 2, right? The following hydrocarbon undergoes, okay, same thing. So how many different forms of R dot are theoretically possible? What's the answer? A. Wow, very stressful, this one. Let's take a look. So let's see how many different types, right? So the first dot, 1, 2, 3, 1, 2, 3, right? So here, same. Good. Here, same. Here, right? Then here, right? And the last one. So 1, 2, 3, 4, 5. Very good. Perfect. A. And then, okay, not bad. Very good. Okay, number 3 is strange. I think like new syllabus, but anyway, it's like sec 4. So what's the answer? Let's see. First option, have or not? Have. Very good. Second option, No, there's SO2 will not reacted, and finally form SO3 the problem, then. Okay, it's also a pollutant. SO2 will not be converted in the catalytic converter. Maybe it's just like that, but this is changed because we form SO3, which is a pollutant again. Right, catalytic converter, you should form harmless products or not pollutants. But okay, more sec 4 CO2 is not totally harmless also right now. It's not a pollutant, but it's a greenhouse gas, right? Very good. Third one, correct. Yes, third one is correct, right? Third one is correct. Fourth one, wrong, because we don't form NO2, allow rubbish. Okay, so answer is B. Perfect. Very good. Not too bad. Okay, first one, answer. Yes, correct. Why? Straightforward. Why? Exothermic. So bond form is exothermic. Okay, so there's only one that strictly bond form. Okay, number 5, a lot of students get it wrong. What's the answer? D is termination step, means 2 radicals. So this one out. Okay, this one out, right? Okay, C out. Wow, very irritating, because A, B, and D also all 2 radical. How?
A is F. The radical is formed from F side.
Why? You're right. Because the CF bond is too strong, understand? Okay, so it will not break or unfavorable, if it really break. So this bond will not be broken. So CF bond normally don't break, so that radical shouldn't exist. Okay, B and D, okay, looks decent, but why? So answer is D, very good, but why B wrong? Because second
is for B, the first radical is formed from C.
Okay, that's okay, that's one thing that you can bother, but the other thing is that if you do a lot, right, H radical shouldn't exist also. Understand? It's more of the energetics side. When you do the bond break minus bond form, it's not so favorable. Okay, so H radical shouldn't exist. So no choice. They purposely put D at the last option. No choice, Okay, so number 6 a bit more tricky. So we need to draw out all of them. Right. So after you draw all of them, the only chiral guy is the which one? Is the second one. Right? And to form that Cl there is 4 positions, correct, that you can choose. So 50%, 4 out 8 positions, 4 out 8 positions, because just to confirm, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then 4 because of the what's it called? This one, 1, 2, 3, 4. And then this one 50%. Very good. Last one, what's the answer? Because there's a tertiary radical. Very good. So tertiary radical is always the most stable, so most readily formed. So answer is C. Perfect. Okay, very good.